So let's continue on with our lesson. Now, here is an important thing to know. I just rewrote this down. Now, I find when I rewrite stuff down, it helps me think about important ideas. It helps to point out some subtleties of the equation. So A times F bx minus h plus k. Okay, fair enough. But if I look at the brackets, if you notice, the h, or the x minus h, is factored out, or you could say the b is factored out from the x minus h. That is, there is the coefficient in front of the x has to be 1 inside the brackets. We'll see that as an example. But given the graph of y is equal to f of x, denote the domain and range. Fair enough. So let's look at the domain of this one. So I'm going to start off maybe by making that a dot and this an arrow here. So this domain, I'm going to call it the domain, goes from 0 to infinity. My range goes from 0 to infinity. That's of my parent function. We are going to write each of the functions in this form, in the general transformed format. And wouldn't you know it, my function is already in there. The coefficient of a is in front of the f, and there really is b is also like that. If you want, you could rewrite it like this to make it really clear. 3f, and in brackets you could put times 2x. So really we have a case where a is equal to 2 and b is equal to, a is equal to 3. B is equal to 2. So I always like to draw this out. If I start off with y is equal to f of x, I'm going to write this in mapping notation. So I start off with point xy. I'm going to make that red or orange. And then if I start off, continue, y is equal to. Now, do I put the 3 or the 2 there first? Well, it doesn't matter. But I'm going to put the 3 in front of the f first. Now, this symbolizes that a is equal to 3. This was a vertical stretch by a factor of 3. So this is really multiplying our y values by 3y. Now, I like to call this building my function, and I'm building my function. The next one is y is equal to 3f. Now, I'm going to put a 2 in front of the x. And really what I've done is I have stretched the x value by a factor of 1/2. Remember, it's often the opposite of what you think. So there we have my function. I've used mapping notation. And sometimes I like mapping notation even before I start transforming my graph. So I have write out mapping notation. The next thing I'm going to do is I'm going to sketch the graph. So I'm going to sketch it out order by order, right? So b was equal to 3. So I'm going to start off with this step first. I'm going to stretch by a factor of 3. So if I stretch by a factor of 3, I have to look at influential points. Like this is a nice point. What makes this a nice point is because the coordinates are integer values. This is also a nice point, and I think that's good enough for me. So if I stretch by a factor of 3, 0.00 stays the same. 1, 1 changes into 1, 3. For 2 is stretched to change to 4, 6. So now I have stretched my graph out by a factor of 3. That's what my graph looks like. There's that second stage. Now, I need to compress the y values by a factor of 1/2. So I start off with 0, 0. I compress by a factor of 2 or stretch them by a factor of 1/2. Really, what am I doing to the x values? I am dividing them by 2 or multiplying by 1/2. So now I take a look at this point and I move this point in. So 1, 3 changes to 1/2 3. Now, 4, 6 now gets compressed by a factor of 2 to go into 2, 6. And that is my function. State the domain and range. Okay, well, I guess describe in words of the transformation. So in words, I would keep in blue, since a is equal to 3, I would vertically stretch by a factor of 3. So since b was equal to 2, my mistake, that should have been 2, we say we horizontally stretch by a factor of 1/2. Alternatively, you could say we compress by a factor of 2. Not so bad, I hope. My domain and range of my transformed graph, the green one, well, my domain goes from 0 to infinity. And my range stays from 0 to infinity. Now, this may seem unexpected, but really, my x values are all multiplied by a constant of 3. And although you may want to say 0 to 3 infinity, no, 3 infinity is just denoted as infinity still. All right. First things first. So, should I start off by making a mistake? I think I will. So here, this is totally wrong, by the way. B is equal to -3. H is equal to 6. This is a very common mistake. So I'm just going to erase that. Whoops. If you notice, oops, my mistake there. If you notice here, the B has to be factored out from the expression in the brackets. Okay, let me try that again. So if I was to take a look at it, I would have to look at it in the following way. Y is equal to F. Now, you would factor out -3 from your expression. And if you factor out -3 from this, you'll end up with x minus 2. There it is in transformed